This topic is about circumcircles and problem solving with circles. I will go through concepts and examples. Feel free to pause whenever you need to. The first thing I need you to do is use a pencil and compass to follow this instruction to construct a circle given 3 points. So you need to draw 3 points first, label A, B, C. Draw 3 line segments to create a triangle. Then construct perpendicular bisectors using your GCSE knowledge of lines AB and BC and label the intersection of the bisectors D. Draw a circle with centre at D and radius AD. And what I want you to check is, does this circle go through points B and C? And after you've done quite a few examples, you'll see that it always goes through B and C. So given 3 points, you could always find a unique circle going through those 3 points, and this is called the circumcircle of those 3 points. So I will demonstrate this briefly using GeoGebra. So I've already drawn the vertices A, B, C, and I've joined it up to make a triangle. So what I want to show is that it's always possible to draw a unique circle going through these 3 vertices. The first thing you need to do is define the perpendicular bisector of A and B. So once you've constructed it, you'll get a line that is perpendicular to A and B and bisects it. If you do the same thing with A to C, so then you get a perpendicular bisector of A to C and a perpendicular bisector of C to B. You see that they meet at 1 point. So all the perpendicular bisectors meet at 1 point. If I make that the center of my circle and use a compass to draw a circle going through any one of those points, A, B, C, you'll see that it goes through all 3 points. The points where all 3 bisectors intersect is the center of the circle, called the circumcenter, and this circle you get is called the circumcircle of the triangle. So let's go through an example. So the points P 316, Q 1112 and R minus 76 lie on the circumference of a circle. Okay, so somewhere on a circle we've got P, Q and R, okay, which are 3, 16, 11, 12 and R, which is minus 7, 6. Work out the equation of the circle. Okay, so we're using the theory from circumcircles to find the equation of the circle. So the first thing I need to work out is the equation of the perpendicular bisector of PQ. Okay, what that means is if I find PQ, which is this, then the perpendicular bisector will go through the center. So remember, it bisects P to Q and is perpendicular to it. Okay, the first thing I need to do is work out the gradient of P to Q, which is change in Y over change in X, which is equal to 16 take away 12 over 3 take away 11, which gives me 4 over negative 8, which is equal to a negative half. That means the gradient of the perpendicular bisector of P to Q is equal to the negative reciprocal of this value, which is equal to 2. Okay, so I found out the gradient of the perpendicular bisector. Now I need to find the midpoint, because obviously if it bisects, the point that it goes through is the midpoint of P and Q. Okay, which is x1 plus x2 divided by 2, y1 plus y2 divided by 2, which is 3 plus 11 divided by 2, and 16 plus 12 divided by 2, which is equal to 7, 14. So now that I've got my gradient of my bisector and I've got the midpoint of my bisector, then using y minus y1 is equal to m times x minus x1. I get y minus 14 is equal to 2 times x minus 7, which is y minus 14 is equal to 2x take away 14, which means y is equal to 2x. So my perpendicular bisector of P to Q is y is equal to 2x. So y is equal to 2x there. Okay, I need to do the same thing for the perpendicular bisector of P to R. So if I have P to R and then I find the perpendicular bisector of it, then it also goes through the center. So next step, equation of perpendicular bisector of P to R. Again, I need to find the gradient of P to R, which is equal to change in y over change in x, which is equal to 16 take away 6 over 3 take away minus 7, which is 10 over 10, which is equal to 1. And the gradient of the perpendicular bisector of P to R will be the negative reciprocal of that, which is equal to negative 1. Now I need to find the midpoint of P to R, which is x1 plus x2 divided by 2 and y1 plus y2 divided by 2, which is equal to 3 plus minus 7 divided by 2 and 16 plus 6 divided by 2, which gives me a value of negative 2 and 11. Again, using y minus y1 is equal to m times x minus x1, I get y minus 11 is equal to m, which is minus 1, times x plus 2, because minus minus becomes positive, which means I get y minus 11 is equal to negative x take away 2. If I rearrange it, I get y is equal to negative x plus 9. So now I've got the two equations of the bisectors. If I want to work out the circle center, I need to solve it simultaneously. So now I need to solve simultaneously. Okay, so I've got solve two equations simultaneously. So I've got y is equal to 2x and y is equal to negative x plus 9. If I put them together, I get 2x is equal to negative x plus 9, which means 3x is equal to 9, which implies x is equal to 3. Now, if x is equal to 3, using either one of these equations that I've got, y is equal to 2x implies y is equal to 2 times 3, which is equal to 6. So that means circle center is 3, 6. So here the circle center is 3, 6. Now I need to find the radius. So if I want to find the radius, I'm going to work out the distance between the circle center and P. So radius is equal to distance between, let's call that C, circle center and P, which is equal to x2 minus x1 squared plus y2 minus y1 squared. So if I do that, I get 3 minus 3 squared plus 6 minus 16 squared, which gives me root of 100, which is equal to 10. And this implies that my final answer will be, because the circle center is 3, 6, it must be x minus 3 squared plus y minus 6 squared is equal to 10 squared, which is 100. So that's my final answer for my question. Okay, the points A26, B57 and C8 negative 2 lie on a circle. Show that AC is the diameter of a circle. Okay, so if I want to place it, A to C is the diameter, so it must go through the center. A is equal to 2, 6. C is equal to 8, negative 2. And B is somewhere here, wherever it is, 5, 7. Okay, AC is the diameter of a circle. Now, if AC is diameter of a circle, that means by the circle theorem that angle must be equal to 90 degrees. So if and only if AB is perpendicular to B to C. So if we can prove that AB is perpendicular to B to C, then we know it's a right angle, which means A to C must be the diameter. So let's work out the gradient of A to B. Gradient of A to B is change in Y over change in X. So it's going to be 7 take away 6 over 5 take away 2, which is equal to a third. Gradient of B to C, change in Y over change in X, is minus 2 take away 7 over 8 take away 5, which gives me minus 9 over 3, which is equal to negative 3. Now, gradient of AB times gradient of BC is equal to a third times minus 3, which is equal to minus 1. Therefore, AB is perpendicular to BC, which implies A to C is diameter by the circle theorems. Okay, part B. Let's go over here. It says write down the equation for the circle. Okay, so first thing I need to do is work out the center of the circle. So center is here. So center is a midpoint of A to C, because remember it was a diameter. A to C is a diameter, so it must be the midpoint of it, which means I need to work out x1 plus x2 divided by 2, y1 plus y2 divided by 2, which is 2 plus 8 divided by 2, and 6 plus minus 2 divided by 2, which gives me a value of 5, 2. Now I need to find the radius. So this center is 5, 2. So if I want to work out the radius, is the distance between the center and any other point. So center and A, let's say. So we are trying to find out this radius, okay? Then that's the square root of x2 minus x1 squared plus y2 minus y1 squared. So if I do that, I'm getting 5 take away 2 squared plus 2 take away 6 squared, which gives me 3 squared plus 4 squared, which is square root of 25, which is equal to 5. So therefore, my equation of my circle will be x minus 5 squared plus y minus 2 squared from the circle center 5, 2 is equal to the radius squared, which is equal to 5 squared, which is 25. Okay, part C, find the area of the triangle ABC. Now it's a right angle triangle, so it's going to be area of ABC is equal to half times base times height, where the base and height is this base and height, okay? So that means first of all I need to work out the distance between A and B. So distance between A and B is equal to 5 take away 2 squared plus 6 take away 7 squared, which is equal to 3 squared, 9, plus 1 squared, which is 1, which is equal to square root of 10. Okay, distance between A and B is square root of 10. Next thing I need to work out is the distance between B to C. Okay, if I do that, I get 8 take away 5 squared plus minus 2 take away 7 squared, which gives me 3 squared, which is 9, plus minus 9 squared, which is 81, which gives me square root of 90. So area of triangle ABC, which is half base height, is equal to half times root 10 times root 90, which is half of root 900, which is half of 30, which is equal to 15 units squared. Next example. A circle has equation x squared plus 2x plus y squared minus 24y minus 24 equals 0. Find the center and radius of the circle. So the first thing I need to do is complete the square. So I get x plus 1 squared take away 1 plus y minus 12 squared take away 144 minus 24 is equal to 0. Okay, if I collect everything up, so I've got x plus 1 squared plus y minus 12 squared minus 1, take away 144, take away 24, gives me take away 169. Okay, if I rearrange it to take the constant over to the other side, I get 169 on the right hand side. That means my center is equal to negative 1, 12, and my radius is square root of 169, which is equal to 13. Okay, part B. The points A minus 13, 17 and B 11, 7 both lie on the circumference of the circle. Show that AB is the diameter of the circle. So if I do a rough sketch, they've said AB is a diameter, so it must go through the center. The center we know is minus 1, 12. A is equal to minus 13, 17. And B is equal to 11, 7. Now, if we want to prove that AB is the diameter of circle, it means that the midpoint of AB must be equal to the center of the circle. So I need to work at the midpoint of AB and show that it's equal to the center. So let's work at the midpoint of AB. Midpoint of AB is equal to x1 plus x2 divided by 2, y1 plus y2 divided by 2, which is minus 13 plus 11 divided by 2, and 17 plus 7 divided by 2. I get minus 1 and 12, which is equal to the center of circle. Therefore, AB is the diameter of the circle. Okay, the point C lies on the negative x-axis and the angle ACB is equal to 90 degrees. So if I draw an axis, and this is C, ACB is equal to 90 degrees. Find the coordinate of C. Okay, so if I'm trying to find C, because C lies on negative x-axis, it implies y is equal to 0. Okay, let me just rewrite that. Because C lies on negative x-axis, y is equal to 0. So I need to substitute y equals 0 into the equation of the circle. Okay, if I do that, I get x plus 1 squared plus 0 minus 12 squared is equal to 169, using this equation here. Okay, if I expand the 0 minus 12 squared, I get 144 is equal to 169. If I expand the bracket, I get x squared plus 1x, which gives me 2x plus 1 plus 144, take away 169 is equal to 0. If I simplify, positive 1 plus 144, take away 169, I get minus 24 is equal to 0. Now if I factorize this, I want two numbers that multiply to give me minus 24 and add to give me 2. It must be positive 6 and negative 4, which means x is equal to negative 6 or x is equal to 4. Now it can't be this one, since x is negative. Therefore, x is equal to negative 6. So the point C is equal to negative 6, 0. The point A, negative 3, negative 2, B, negative 6, 0, and C, 1Q lie on the circumference of a circle such that BAC is equal to 90 degrees. So if I draw a rough sketch, B, A, and C is equal to 90 degrees, okay? Where B is equal to minus 6, 0, A is equal to negative 3, negative 2, and C is equal to 1Q. Now, because angle BAC is equal to 90 degrees, we need to find the value of Q. That means gradient of A to B must be equal to the negative reciprocal of gradient of A to C. Okay, so using that factor, let's work out the gradient of A to B. So gradient of A to B is change in y over change in x, which is equal to negative 2 take away 0 over negative 3 take away negative 6, which gives me negative 2 over 3. Because gradient of A to B is negative 2 over 3, it means that because it's perpendicular to A to C, gradient of A to C must be equal to negative 1 over minus 2 over 3, so the negative reciprocal of this gradient, which gives me 3 over 2. So gradient of A to C is equal to change in y again over change in x, which is equal to q minus minus 2 over 1 minus minus 3, which is q plus 2 over 4. Now, gradient of A to C is 3 over 2, and also q plus 2 over 4. So they must be equal. So q plus 2 over 4 must be equal to 3 over 2. If I multiply both sides by 4, I get q plus 2 is equal to 2 times 3, which is 6. So q must be equal to 4. Okay, part B, it says find the equation of the circle. Now, because this is a right angle there between angle BAC is equal to 90 degrees, that means, according to the circle theorem, B to C must be the diameter. Okay, so since angle BAC is equal to 90 degrees, B to C is the diameter of the circle, which implies the radius, sorry, not the radius, the center. The center must be equal to the midpoint of BC. So midpoint of BC is -6 add 1 divided by 2. And remember 1 cube, because we worked out it's 1/4. Then midpoint of our y values will be 0 plus 4 divided by 2, which gives you a value of -5/2. -5/2, and let me just rewrite that because it's not very clear. -5/2 and 2. Okay, now the radius is half the diameter. So radius is half diameter. So I need to work out the distance between B to C. Okay, let's work out this distance, which is half times distance of B to C. Half of square root of 1 take away -6 squared plus 4 take away 0 squared, which is half of 7 squared, which is 49, plus 4 squared, which is 16. And that means you get half of root 65. So if I want to write the equation of my circle, I'll get x plus 5/2 squared plus y minus 2 squared is equal to half root 65 squared. And if I want to simplify this further, I get x plus 5/2 squared plus y minus 2 squared is equal to 65/4. And that would be the equation of my circle. The circle C has radius 5 and touches the y-axis at the point 0,9 as shown in figure 4. Write down the equation for the circle C that is shown in figure 4. Now, because the circle center is here, I know the x value is negative, so the radius is 5. So that means because the x value is negative, that must be -5. And the y value must be 9 because it touches the y-axis at 9. So the center is equal to -5, 9, and the radius we've been given, which is 5, which implies that the equation of the circle will be x plus 5 squared plus y minus 9 squared is equal to the radius squared, which is 5 squared, which is 25. A line through the point P, which is 8, -7, is a tangent to the circle C at point T. So somewhere 8 minus 7 will be in this quadrant. So this is P, which is 8, -7. And is a tangent, so somewhere it meets the circle at T. So let's call this T. And we're trying to find the length of PT. Okay, so we're trying to find the length of PT, this length. Now what we do know is, because P to T is a tangent, then it makes a 90 degrees with the radius, okay? And if we join P to the center, then we have a right angle triangle. So let's call this circle center C. No, we can call it C. Then first thing I need to work out is the distance between P to C, which is x2 minus x1 squared plus y2 minus y1 squared. 8 minus negative 5 squared plus negative 7 take away 9 squared. Square root of 169 plus 256, which gives me the square root of 425. Now, because we have a right angle triangle here, if we call this distance of P to C, if we call this side distance of P to T, and this is radius, then I know according to Pythagoras theorem, which is a squared plus b squared is equal to c squared, according to that theorem, then I know that the distance between pt squared plus r squared must be equal to the distance between pc squared. Now, the distance between pt is what we're trying to find out, so let's just leave it as an unknown. Radius squared is is 5 squared, and distance of P2 squared is square root of 425 all squared. So if I simplify this, I get 25. Square root of 425 squared gives me 425. So distance of PT squared is equal to 425 take away 25, which is 400, which means distance of PT is square root of 400, which is equal to 20. And that is the solution.